This week we are focusing on Chapter 18, Chi-square. So far throughout the semester we've been working with variables that have been continuous, such as temperature, distance, weight, bank account balance, mood score, height, grade point average. Now we're going to shift gears and look at categorical variables this week. So, for instance, categorical variables can also be considered as nominal, and this could be categories such as gender, male or female, race, Catholic, Baptist, Protestant. I'm sorry, I'm looking at religion here. Religion, Catholic, Baptist, Protestant, race, blood type, marital status. So categorical variables can fall into a number of categories. And so variables that contain only two categories are called dichotomous. And so this would be, for instance, gender, where there's only two categories, male, female. Voter status, registered or not registered. Opinion, yes or no. Attendance, present or absent. Or grade, pass or fail. Now, we can also have categorical variables that have any number of categories. And so, if we have a variable that contains more than two categories, that is considered a polycotomous variable. And this would be, for instance, appointment status. You can have 5 different categories here: on time, late, canceled, no-show, rescheduled. Marital status: single, married, separated, divorced, widowed. Ice cream preference: you can have various ice cream preferences. And visual aids: there's from none, glasses, contact lenses, surgical correction. So a polycotomous variable has more than two categories. Now let's look at chi-square, because chi-square is the test that we're going to use to compare categorical variables to each other. Now we're looking at the correlation between two categorical variables. So remember when we did correlation tests, we ran a correlation test to look at the relationship between two continuous variables. Now, in order to look at the correlation between two categorical variables, we would use chi-square. And chi-square is sometimes written as our little x here that's italicized with the superscript 2. And fortunately, the chi-square does not need you to specify how many categories are in each variable. So when you're placing in those variables to run your analysis in SPSS, it really does not matter how many categories each variable has. You just pop your categories in, place your categories in, and SPSS will do the rest. So you won't have to specify how many categories for each variable. It can officially handle a mix of dichotomous and polycotomous variables. So you can analyze the relationship of one dichotomous variable with a polycotomous variable. So it really doesn't matter. SPSS can handle it. And it organizes, the chi-square organizes the data from each categorical variable into a grid, and it compares the categories to each other and then produces a p-value. So if the chi-square produces a p-value that is less than 0.05, this will indicate that there is a statistically significant difference among the categories. And of course, if your p-value is greater than 0.05, it will indicate no statistically significant differences among the categories. So let's look at a question that a chi-square test could possibly examine. So here is a question here. It says, is gender correlated with ice cream preference? So in other words, do girls and boys tend to select the same ice cream preferences, or are there differences in their preferences? If the p-value, so once we would run our analysis, if the p-value is less than 0.05, we can then say that there is a statistically significant difference between the girls' ice cream preference and boys' ice cream preference. Girls like ice cream flavors. Girls like different ice cream flavors from boys. Alternatively, if the p-value would be greater than 0.05, we would then say that there is no statistically significant difference between the genders when it comes to ice cream selection. Boys and girls like similar ice cream selections. So let's recap here for a minute. So chi-square can be used to compare categorical variables with the same number of categories in each variable, such as gender to opinion. If we're looking at gender, gender only has 2 categories. Opinion has 2 categories. So in this case, chi-square would create a 2 by 2 chi-square table. Now notice where the 2's come from. Each number tells me how many categories are in the variable. So gender has 2 categories, male and female. Opinion has 2 categories, male and female. Now remember I said chi-square can also analyze categorical variables that have a different number of categories. So for instance, what if I wanted to examine the correlation between gender to blood type? So gender here only has 2 categories, however blood type has 8 categories, and this would produce a 2 by 8 chi-square table or an 8 by 2 chi-square table. And this is purely depending on how you choose to load the variables into the rows and columns. Each way, your analysis would be the same. So when it comes to chi-square, it does not matter which variable you place in the chi-square table. You can place one in the row, one in the column, you can reverse it. Either would produce the exact same results. Now, there are 2 assumptions for chi-square test, and the first assumption is independence. Each person contributes to only one cell of the chi-square table. So, for instance, going back to our example here, each person contributes to the chi-square table only once. So for instance, if I am asking males and females what their ice cream preference is, each person can only tell me one ice cream preference. I can't say, give me your top 2 or give me your favorite 2, because then each person would be contributing to more than one cell of the chi-square table. So in order to complete a chi-square table, one of the assumptions is independence. So basically, each person can only give one answer to the question, or they can only contribute once to the data collection. So there could be there can be several questions that you're asking, but each person can only answer each question one time. What is your favorite ice cream preference? Chocolate. Only answer. Or strawberry or vanilla, but only one. However, if you do come across, so for instance, what happens if you do have a survey where you're asking someone, please circle your top 3 choices, for instance, or your top 2 choices, and your variables are categorical. What do I do? It seems like I might be able to complete a chi-square table, complete a chi-square analysis, but my data, that it's not independent. It's not, I'm not meeting that chi-square assumption. There is actually a chi-square test that you can run It is an advanced statistical test. Unfortunately, you cannot use chi-square with it. I remember looking into it at one time, and I had to use the program R to complete this chi-square test, and unfortunately, I don't know how to use the program R, and so a lot of coding is involved. So I actually I put that off to the side. It's on my to-do list, but so there actually is a way to run your data, to run a chi-square test. It's a different chi-square test. It's a much more advanced statistical test, but for purposes, for our means, and the most commonly used chi-square table, I remember lots of you said, several of you at least said that the articles that you come across in your field have chi-square tests quite a bit. And those chi-square tests that you are reading in those articles are following these assumptions. One cell, each person contributing to one cell. And the next one is expected frequencies, which each square cell should have at least 5 entities. And I'm going to show you what that means in just a second. Here is a chi-square example that we're going to look at. So for this particular study, a researcher will recruit a group of participants to ask each person to complete the following questions on a self-administered anonymous survey card. And these are two of the questions that each person answered. What is your gender, male, female? What is your political party affiliation? And for each question, they could only give one answer. The hypotheses for this particular example, we can say null hypothesis, there is no correlation between gender and political party affiliation. Our alternative hypothesis, we can say there is a correlation between gender and political party affiliation. Two categorical variables here. We have gender with 2 categories, and then we have party with 3 categories. So let's check the assumptions here. We will say that our data are independent because each person is answering each question only once. Now let's look at expected frequencies. Now remember I said that there has to be a minimum of 5 in each cell. So let's look at this. Gender has 2 categories, female and male. Party has 3 categories. So the chi-square test, the chi-square table that is created here would be a 2 by 3. 2 by 3. So there's a total of 6 cells that would be in this particular table. So if I said that each cell should have at least 5 entities, I'm talking about these cells right here. So I'm saying for this particular cell, female and Democrat, so I should have, in my data set, I should have at least 5 females who are Democrat, at least 5 females who are Republican, and at least 5 females who fall in the other category. Same with male, at least 5 male Democrats, at least 5 male Republicans, and at least 5 other. So it should have at least 5 entities, would mean, so if I say 5, 10, 15, 20, 25, 30, so that means we should have a minimum of 30. We should have a minimum of 30, so that means our N should be at least 30. However, it definitely needs to be more than 30. Because, for instance, if we say that it needs to be at least 30, 30 would presume that the participants' responses will fill the 6 cells evenly, 5 per cells. And realistically, that, of course, this is probably unrealistic. So let's consider 30 as the minimum. So we're going to say 30 is the minimum, but we will say it needs to be more than 30. So that total N, which means our sample size, we need to have a sample size of more than 30. And in order to view the counts for each cell here, this will actually be part of the results section in a few minutes. So let's run a chi-square test. On Blackboard, you can go ahead and open up the SPSS file. Chi-square example.
Okay, we have our two variables here, gender and party. And notice our gender is coded as 1, 2, party is coded as either 1, 2, or 3. So let's click on Analyze, Descriptive Statistics, and then Crosstabs. Now, let me just tell you that I'm going to be selecting just a few less options than our book is selecting. So I'm just simplifying the process just a little bit. So if you would prefer to follow the step-by-step procedure in your textbook, which is very, very, very similar, however, I'm just eliminating just a couple of options in SPSS just to simplify the process, but either would be correct. So in order to run our analysis, we'll place gender in row and party in column, and remember, it doesn't matter which one goes where. You could easily put party in row and gender in column. And another option that I would like you to click on would be display clustered bar charts, because this will be this is a good visual to see what your data look like. Let's also click on statistics, and we will check chi-square, continue, and OK. Alright, let's begin by inspecting the cross tabulations table. And notice this is the chi-square table where I was saying that you should have a minimum of 5, at least 5 in each cell. And so each cell should have a count of at least 5. And so we do. 5 is our minimum here. We have 16. We actually have 16 females who are Democrat, 9 females who are Republican, 6 females who fall in the other category, 6 males are Democrat, 18 males are Republican, and 5 males fall in another political party. And so each one does have at least 5, so our assumption, it has been met. And so if we look at our next table, our chi-square test, we can see Pearson chi-square, and if we look at our significance p-value here, which is 0.023, this is less than 0.05, so we can confidently say that there is a statistically significant difference among genders when it comes to political affiliation. And here is our bar chart. And notice we have, it shows here which color denotes which party affiliation. And so here are our females and our males. And you can clearly see here our females are mostly Democrat and our males are mostly Republican. So a nice visual to further examine your data. So now that we have our SPSS results, Now let's go ahead and document our findings here. So notice we went through here, but I also want to bring your attention, notice it also shows us a total. So we have our total Democrats, which are 22, total Republicans 27, total other, and this total equals 60. The same thing with our females and males. Notice our total females, we have 31 females, 29 males, which is a total of 60. So our N is 60. Remember we said we needed our N to be more than 30? Well, we are just fine because our N is 60. So now that we have these results, let's put it together and write up our results. So we can say, according to a survey of 60 adults, we detected a statistically significant p-value of 0.023 at an alpha level of 0.05 in political party affiliation based on gender. Of the 31 females surveyed, most are Democrats, 16 Democrats, 9 Republicans, 6 other, whereas the 29 men in our sample were predominantly Republicans, 6 Democrats, 18 Republicans, 5 other. So notice, not only did we give our significance results, but we also tied it into our clustered bar chart as well. Hopefully you feel a little more comfortable reading, interpreting, completing chi-square tests.